cardinal number of a set. Results based on cardinal number of sets. The cardinal numbers of mutually joined sets and their relations. N of A equals to number of elements present in A. N of B equals to number of elements present in B. N of A minus B equals to number of elements present in A but not in B. Only A. N of B minus A equals to number of elements present in B but not in A. Only B. N of A intersection B equals to number of elements present in both A and B. N of A union B equals to number of elements present in either A or B if N of A minus B equals to X. N of A intersection B equals to Y. N of B minus A equals to Z, then N of A equals X plus Y. N of B equals to Z plus Y. N of A union B equals to N of A plus N of B minus N of A intersection B. N of A minus B equals to N of A minus N of A intersection B. N of B minus A equals to N of B minus N of A intersection B. If A, B, C are three non-empty mutually joined sets, then N of A union B union C equals to N of A plus N of B plus N of C minus N of A intersection B minus N of B intersection C minus N of A intersection C plus N of A intersection B intersection C. Point 1. N of A union B equals to N of A plus N of B if A, B are disjoint sets. Point 2. N of A minus B equals to N of A when A and B are disjoint sets. If A and B are equal sets, then N of A union B equals to N of A intersection B. If A is a proper subset of B, then N of A union B equals to N of B. N of A intersection B equals to N of mu minus of N of A union B whole dash plus N of A delta B. N of A union B equals to N of A minus B plus N of B minus A plus N of A intersection B. N of A minus B equals to N of A union B minus N of B. N of B minus A equals to N of A union B minus N of A. N of A delta B equals to N of A union B minus N of A intersection B, or equals to N of A minus B union N of B minus A. If A proper subset B, then N of A minus B equals to 0. N of A union B equals to N of B. N of A intersection B equals to N of A. If A and B are disjoint sets, then N of A minus B equals to N of A, n of b minus a equals to n of b. If n of A union B equals to 1, then point 1. One of the sets A, B is a null set and the other set is singleton set. Point 2. Both the sets A and B are equal sets and singleton sets. If n of A union B equals to 0, then both the sets A and B are null sets. If both the sets A and B are equal, then n of A intersection B is maximum. N of A union B is maximum if A union B equals to mu. N of A dash union B dash equals to n of mu minus n of A intersection B. N of A dash union B dash equals to n of mu minus n of A union B. N of A delta B equals to n of B delta A. N of A delta B equals to n of A when B is null set. N of A minus of B union C equals to n of A minus n of A intersection B minus n of A intersection C plus n of A intersection B intersection C. N of set of elements which are in exactly two of the sets A, B, C equals to n of A intersection B plus n of B intersection C plus n of C intersection A minus 3n of A intersection B intersection C. N of set of elements which are in at least two of the sets A, B, C equals to n of A intersection B plus n of A intersection C plus n of B intersection C minus 2n of A intersection B intersection C. N of set of elements which are in exactly one of the sets A, B, C equals to n of A plus n of B plus n of C minus 2 minus 2n of A intersection B minus 2n of B intersection C minus 2n of A intersection C plus 3n of A intersection B intersection C.